Okay, so let's get started. Hey everyone, nice to see all of you again on our bi-weekly webinar slash meetups that we have been trying to be consistent now going forward. So every 2 weeks or every few weeks, every Thursday, you will see something else. This one was supposed to happen last week, but then with some challenges, we had to move it on. So it's happening now, but we have some more coming in the next 2 weeks as well. I think every Thursday we have something going on here. Cool. I'm Praveen Salitra, Head of Technology here at Egen, and then also mostly doing my day-to-day work with cloud architecture. And today, the focus that we have is on something interesting that is coming from all of our experience across 10, 15 projects, customers slash product platform, whatever we have been developing. So let's talk about Egen. We are based here in Naperville, southwest suburb of Chicagoland. And then what we have been doing is actually we are a cloud native data engineering firm. We are also heavily are invested in cloud modernization for some of the enterprises that we have been helping them. So we have built solutions using cloud native architectures, mostly on the data engineering side, whether it's streaming data, whether it's big data, or kind of things for startups and enterprises for the last, 5-6 years. So the organization is almost now 21 years old, but then our solution arm, where most of our folks are working right now here in Chicago. So the solution arm was created almost 6 years ago. And the idea was to work with some of the top valued unicorns of Chicago at the start. But then now all that learning we are distributing in public, but then also helping some of our newer customers, which are some other startups in Chicago, but then also some enterprise customers at this point. So in case of our experience, just to give a highlight, coming from last 6 years of our work, especially with cloud and data. So we have heavily worked on industrial IoT, working with a couple of OEMs, top OEMs in the world, dealing with streaming data coming from sensors installed on the machines. Or in the last 2-3 years, we have also ventured into healthcare. Again, a couple of customers there, large customers, where we are dealing with healthcare data. Not that streaming data, but mostly batch, but still large files that we are dealing with. And mostly when we are thinking about bioinformatics or genomics, that's where a lot of our exposure is coming into at this point. And then, of course, more and more we are going in retail and fintech as well, whether it's working with some grocery delivery services globally or some startups from Chicago who are into the retail world. A couple of months ago, we started our first fintech project here as well at this point as an audit tool for auditors, the financial auditors and things like that. So that's where all of our experience is coming from. And then again, these are all the projects in the last 5-6 years or so. The whole idea here at Egen, or at least in Cloud Collective, to share all of these learnings from this bleeding edge solutions, platform, technologies, frameworks that we have been using internally, and we have learned about how to use them and how not to use them. The second one is more important. And stuff that our product and engineering teams are developing or trying out or experimenting day to day. So all these ideas, all these concepts coming from there, and of course, mostly in all of these products that we have seen, right? We have been dealing with some unknown territories. We have been charting some unknown territories. We were one of the first ones to utilize Kafka at the scale of industrial IoT almost 6 years ago. We started working with microservices from that time, and now we also know where it doesn't work and what are the downsides, not just the good things. Same thing goes with serverless, not just lambdas or functions, but then also utilizing many other services in that fashion, whether those are CI/CD services, whether serverless databases that you have, or anything, right? A managed service where you have pay-per-use model and things like that. And that's the focus today as well. So usually I go in detail and talk about the technology stack that we have been working with. I'm just gonna skip it today. And of course, hiring, we are always hiring for all type of roles. Mostly we are an engineering and product organization, so that most of the roles you will see there, but then other sort of functions as well in the company that we are hiring for. So head over to egen.solutions/careers. If you are already working here, please refer to your friends or your colleagues or someone who know would like to work here and then enjoy experimenting and dealing with this day-to-day technical challenges that we are going through. So that brings us to the idea for today, right? What are we going to be discussing? So we have Varun. He is our software engineer working on one of the project with a healthcare unicorn, I would say now, from Chicago. So the idea for this particular meetup came from our experience of dealing with self-hosted CI/CD services almost within the last, I would say, until 2 years ago. So anything prior to that, right? Jenkins, or even in the past, if you remember Hudson, which is where Jenkins originated from, right? And all those kind of things, but then doing or managing a self-hosted cluster internally on with some enterprise products. Of course, we used to have, and we on some other side, we still have some teams managing these self-hosted clusters, right? The team who will write the automation, take care of all that pieces of pipelines. I mean, Jenkins went from do everything from UI to pipeline as a code, and now many other things are also coming up. What we have learned over the last 3-4 years in this business, specifically on CI/CD services, that some of these cloud managed CI/CD services, those are also getting stronger and stronger and more popular, such that we have started using them for some of our newer projects, especially for the startup world. You don't have, first of all, teams to manage your self-hosted cluster, right? And you are already on the cloud providers. So why not use some of those services? Pay per use, easy to configuration, quote and unquote, I would say. So that's the whole idea for this particular meetup. So I will hand it off to Varun, and he will walk you through some of the pros and cons, and we will have at least 4 of this CI/CD group of services from 3 cloud providers and GitHub, and then we'll walk through how to configure. We have a demo running as well. So Varun, all up to you. I'm just gonna stop sharing the screen and you can get started.
Sure. Give me 1 second. So thank you, Praveen, for introducing me. As Praveen already mentioned, my name is...
You are sharing a wrong screen.
What am I sharing?
I see 4 windows there. So,
Oh, wait, hold on.
yep.
Yeah, that is correct. Yeah, that was what I wanted to share. That's correct. Oh, so I'll go into detail why I'm that.
Okay, got it. Cool.
Yeah. As Praveen mentioned, I'm Varun. I am a software engineer at Egen, and today's topic is basically running CI/CD on each of the 3 cloud providers, CI/CD services using each of the 3 cloud providers, and also leveraging GitHub Actions, which is like a new and upcoming um, CI service, right? So the purpose why I have these 4 windows open over here is so that it makes it easier for the demo. So this is basically these, if you go over here, these are the containers running on each of the cloud providers. So this is running on AWS, this is running on Azure, this is running on GCP, and this is running on Google Cloud Run. And I will explain in detail moving forward when I go into each of the CI pipelines of how they're configured. And we'll also make a small change and see it go through each of these pipelines. If we are fast enough, we would be able to see the pipelines running in real time as well over here. But let's see how it goes, right? So yeah, let me start the presentation. Right. So the big picture is CI service, right? First of all, why do we need CI service? So CI service, it usually involves developers updating new code or code changes to a common repository, which is then tested, built, and uploaded, right? So by automating these process, what users can do is they can immediately test it and make sure that their code is sound, there's no breaking changes, and it prevents delays in delivery of new software applications or features, and even bug fixes, right? So as Praveen mentioned earlier, let me just move this. As Praveen mentioned earlier, we had like CI/CD workflows using Jenkins cluster, which were like self-hosted, self-managed for our clients. But with the advent of cloud managed services, we wanted to take a closer look at since they are like at a stage where we can consider them to be mature. We wanted to take a closer look and compare it with like the existing like self-hosted or self-managed workflows in terms of setup or ease of setup and use, benefits versus risks, and cost, right? So moving on, let's see what's out there currently, right? So we have AWS, Azure, and Google Cloud as our three main cloud providers, which we'll be looking at. And then we have GitHub, which started off as a source repository, developed into a developer tool, and now it's making its way towards a complete solution for project management, as well as a developer tool, as well as a source repository, right? So for AWS, the services we have available are code commit, code pipeline, code build, code deploy, and the container registry. For Azure, we have what we have available is Azure Devops services, which includes all these things, which are like Azure boards, repos, pipelines, test plans, artifacts, and container registry. For Google Cloud, the services we have available are source repositories, build, container registry, and cloud test lab. For GitHub, we have Git repositories, GitHub Actions, which is newer, GitHub Packages, which is even more newer, right? To manage packages, basically store your packages. So AWS, if you see overall, you'll see they are all developer tools, whereas Azure is like project management plus developer tools. Google Cloud is mostly developer tools, and GitHub is like basic project management and development, right? So moving on to AWS developer tools. So if you look at this image, this is what we have, right? Like code commit, code artifact, code build, code deploy, and code pipeline. So let's go over each of them, what they represent. So code commit is nothing but a version control source repository which is based off of Git, right? Code pipeline is a continuous delivery service for fast application updates. So you can like build, test, and deploy your code whenever there's a code change, or you can specify whichever conditions you want when you want to run the code pipeline, right? Code build, how is it different? It's a fully managed continuous integration service, right? So code build and code pipeline kind of work in tandem with each other to provide a complete managed integration service, right? To build, run tests, and deploy your code. Code deploy is used for deploying the code. And then code artifact is used to store your artifacts, be it Docker images, be it NPM packages, or any sort of basically artifacts. So let's look at a sample build spec YAML for AWS for AWS code build. So this is like, it's divided, as you can see, it's divided into phases. So this is a pretty simple YAML file. If you guys are like familiar with YAML syntax, it's like there are 4 phases to this particular YAML file, where you do installation. In pre-build, you can run your unit test, you can run your end-to-end testing, or you can do any sort of pre-build things that you want to do, basic setup environment, or like whatever you want. And then build is where you would build your package. In post build, you can create an artifact, and in artifacts you can like you can mention what's the target of your artifact and store your artifact. You can have multiple phases, like a deploy phase, where you would deploy it to wherever you want to. Basically, in our case, it's Kubernetes, but I'll go more into that a little later. So let's look at the good, the bad, and the ugly for AWS developer tools, right? So firstly, it's fully managed. So you don't have to worry about networks or hardware management, or even even getting packages or like installing, let's say, apt-get or installing various bash scripts which are required for your packages. And a lot of these things are already come pre-installed, or there's like there's even like there's even certain there's even certain versions of Node or everything available. So it's like fully managed. And then you can also maintain your build artifacts using code artifact or S3. You can maintain your a history of your build artifacts. What AWS provides is custom build environments or predefined build environments. There's no community environments available, which could be a good thing, could be a bad thing, depending on how you look at it, because there's always a chance with community things where it could be malicious, right? So let's talk about pricing. So the free tier for AWS includes like 100 builds per minute per month on their smallest machine, or else it's like pay as you go per minute model. And most of these cloud providers have pay as you go per minute model. There's no dependency caching. Why is dependency caching necessary, right? So caching dependencies and build outputs usually improves workflow execution time. So your builds are faster. If you have a small code base, it might not matter, but if you have a larger code base, this is like pretty important. There's no managed integrations for multi-cloud support. So meaning if I wanted to deploy to let's say a Google Cloud run from AWS, I would have to manually install by hand the Google Cloud SDK, configure it on my agent, on my worker agent, and then I have to do it. Basically, it's the same thing as how we would configure on a self-hosted VM or wherever, right? There's not much support for code deploy outside Lambda EC2 instances. Yeah, so basically this is secure in terms of Azure world. So AWS can be thought of as since it doesn't expose a lot of things, it doesn't allow integration with, it's like considered to be more secure. Now let's move on to Azure DevOps. As I said, Azure DevOps includes all of these services, which are boards, which boards are used for project management, repos. Again, I'll go into detail once I go through the animations. So as you know, Azure DevOps provides full project management and developer tools suite, which means that we can use boards to create Kanban and our sprints or backlogs, and we can work through them, and it will basically allow us to keep track of the issues we are working on at one place, right? So yeah, Azure repos, it provides Git repositories. It also provides team foundation version control, which the others as of like right now do not support. Azure Pipelines, it provides build and release services to support integration and delivery of your application. So Azure Pipelines is where you would run your build pipelines or your test pipelines, your linting, and all those checks, right? Azure test plans, this is similar to, I don't know if you guys work with Zephyr or not, but basically you can create your test plans, and then they can be manual, they can be automated, and you can basically create a gated release where, oh, if all these test plans pass, then I can do a gated release of my image as well. Azure artifacts, again, the same concept where you would store your artifacts, NPM, Maven, NuGet, or your Docker containers currently. So this is what Azure Pipelines looks like. It's YAML supported. It's pretty similar, pretty straightforward. There's like variables you can define on top. Oh, sorry. There's like variables you can define on top. There's like multiple stages you can define. So there's a build stage, and then you can have multiple jobs inside each stage. So you can basically segregate your workflow in stages, and then you can have each you can have multiple jobs running in each stage. So your build stage could have, let's say, lint check, test check, and then building the Docker image, right? Something similar to that. Azure DevOps, again, fully managed. You don't need to worry about managing hardware, network, or anything. Of course, when I say that, I'm talking about like manual management of that. Like you still have to configure things online using service accounts and everything, but that's like still minimal configuration rather than when it's self-hosted. It is a one-stop shop for project management and developer tools. So if you saw the previous slide earlier, there's like one place you'll see everything, which I'll go into more detail during the demo as well. There's automatic labeling. So automatic labeling is important because it makes project maintenance easier. And not only like labeling based on files modified, but for also other reasons, right? Like let's say the file size of change is big, so I can label according to the size of change, which could speed up the maintenance of my project, right? Yeah. Let's see. So there's multi-cloud supports now. Azure DevOps, one thing it has is actions, and there are like third-party actions available. So you can have actions from Google Cloud Provider to deploy to Google Cloud, and you just need to provide like secrets over there. And it like you don't have to worry about installing Google Cloud SDK, configuring or anything. Like the actions take care of everything. Then workflow files are using YAML or ARM. ARM templates are basically Azure Resource Manager templates where you could specify what infrastructure is needed and it could reside within, like right next to your code. This is helpful because you can have, let's say, if you have a high risk feature being deployed, you can modify your ARM template on a feature branch and push it out to an instance, and then you can do your testing over there. And then once you can do your regression testing, you can do your smoke testing, and then once it's validated, you can basically do a gated release and then deploy it to your main branch. Or you can also use it to do canary deployments where you basically route, like let's say 10% of your traffic to these set of nodes, and then 90% of your traffic to main nodes. And if 10% of the traffic doesn't get affected, you switch it to, like, let's say all the traffic, you route all the traffic to your main node, which is very important. Again, caching dependencies and build outputs to improve workflows. Then there's community of devs maintaining actions, as I said earlier, which can be a good thing, can be a bad thing. There's support for self-hosted runners, which is important. So if you have like an existing runner, which you want to use for DevOps, or if there are like security concerns around using public runners, you can have your own self-hosted runners as well. There's binary authorizations, which is basically like a gated release. Like there's an image, you pull down the image, you see, oh, you can sign off on the image, or you can sign off on the image. If it looks good to you, then you create a release, or then you allow a release process to be executed after that, right? In terms of cost, there are various licenses available, from pay as you go to pay per user per month. You can also do like each service cost separately. For example, when I say each service, meaning like I can just pay for boards, or I can just pay for pipelines if I'm not using. So there's like a plethora of licenses available that you can tailor for your own particular needs. This is especially useful when you have a startup, when you have, like, let's say 2 developers in a startup, and then you do not know your entire cost. So instead of paying for the whole thing, you can just pay for what you need. Then again, with third party comes malicious actions. You will always have to make sure that these actions do not change your artifact in any way, or do not add malicious code on runtime into your builds. So you have to be careful when using third party or like community actions. Moving on, to Google Cloud. Google Cloud consists of cloud source repositories, cloud build, container registry, and cloud test lab. If you see on the left, this is how it is organized on the UI. So cloud build is a service that executes your build. So cloud build, this particular thing is very interesting because Google Cloud build can import source code from cloud storage, source repositories, GitHub or Bitbucket. What is important is maintaining your source code in cloud storage, which I don't know how people feel about that, but it's something available with Google Cloud. Yeah. So moving on, there's artifact registry where you can store your artifacts, your npm packages, maven packages, pypi packages, Docker containers, and everything, or in container registry as well. So source repositories are fully featured private Git repositories, which are hosted on Google Cloud Platform, similar to GitHub, similar to code commit. Yeah. And this is a sample cloud build YAML file. Over here, you can see I'm using a cloud builder. So builders are nothing but, let's say, actions, or like a builder can be used. Like there's minimal configuration over here required, right? Like once you have a builder, you provide the proper authorizations in your secrets. You don't have to like configure a whole lot, right? Basically, it's just like you use the builder, you build your image, you push the container image, and you deploy the container image to wherever you want to deploy to. Yeah. So now the good, the bad, the ugly with Google Cloud. Again, it's fully managed. Now workflows in Google Cloud files can be written in YAML and JSON. So there's support, like if I don't like YAML, I can use JSON file over here, which looks different. But in my case, since I'm used to YAML, I just use YAML for each configuration. There's multi-cloud support again, because there's like third-party builders available as well. So over here, you can create, so you can use either Google's own cloud builders, you can create your own custom builders, or you can use one of the community maintained builders as well. There's like a repo available for all the builders you can go through. Yeah. Again, caching dependencies and build outputs. You can put your build outputs in artifact registry. You can just maintain it. There's predefined builders, custom builders, or community builders, which I said. One thing Google claims is it has extremely fast builds, which I have seen myself as well. And I was very surprised by it. But yeah, the one thing it does is it is very, very fast. There's free, based, so for the cost, it's free for 120 build minutes per day, with 10 concurrent builds included. And then after that, it's pay as you go per minute model. This is like sufficient for a lot of use cases, in my opinion, but yeah, depending on organization's need, it could change for each particular organization. Again, binary authorizations are available in Google Cloud, which means you can sign off on your particular image and then do a deploy. Again, with third-party builders, there's malicious builders available. One thing I want to point out in Google Cloud is that if you see, there's no mention of which version of the builder I'm using, or there's no mention of the SHA that I'm using or the hash that I'm using to deploy, right? So I can basically, this always fetches like the most recent builder. So you can be sure that it's like latest with all the, whenever your pipeline is run, it's the latest build, and then it is basically it has all the features of the latest release, right? Again, with third-party builders, one needs to make sure, because you don't know if it's like properly tested or not, so one needs to make sure that it's properly tested, and like it meets all the security standards for your organization. Moving on to GitHub. GitHub developed as a repositories. It introduced GitHub Actions late 2019, where you could do CI/CD deployments, and GitHub Packages is something, it's still in beta, where you can create, say, for example, Docker images, and you can publish the Docker images to GitHub packages, basically, which is pretty cool. So GitHub repositories is the de facto service for open source control. More and more customers are moving towards it. Also, it has integrations with all major cloud providers currently, so it is being widely used right now. GitHub issues and projects is which I was talking about, GitHub's foray into basic project management right now, where it provides a basic issue and roadmap management, and it's mostly helpful for the OSS projects and tracing the isolated tasks. Right? So GitHub packages, you can maintain GitHub packages, and it provides a way to safely publish and consume packages within your organization or within the entire world. Currently, let's say if you're building a Docker image, the Docker authorization is done through personal access tokens only. So to pull, you would need to provide the personal access token, which, because it's in beta right now, it's still ongoing, right? GitHub Actions are event-driven, meaning that you can run a series of commands. So we'll see GitHub Actions in later slides, right? So this is GitHub Actions, right? So GitHub Actions are event-driven. So let's say I have an event where I push to master branch of my repository. I create a job for that task, and then I have multiple actions that I can perform in that job, right? And then my runner will run the action and it will log the results. It's a pretty straightforward diagram. So another cool thing with GitHub, using GitHub, is you can make use of these integrations like Dependabot, LGTM, Snyk, to make sure your code is production ready. Yeah. So this is a sample GitHub workflow. In this, we are doing nothing but we are just checking it out, checking out the repo. We are building the image, we are pushing the image, and we are deploying it to Google Run, right? Cloud Run. An important thing to see over here is, as compared to builders, was we are tagging it with @v2, or so this is like version 2. So this needs to be maintained manually, or like updated manually whenever a new version is available, which is something to be mindful about when using GitHub Actions. So the good, the bad, the ugly for GitHub Actions. Again, it's fully managed. You don't need to worry about hardware, network management. In fact, even if your artifact, if your build is large, it dynamically scales up and down the agent. So you don't need to worry about, oh, if my build is too big, maybe it won't get deployed. There's automatic labeling available in GitHub Actions, which is another, I talked about it earlier. So just a refresher. Labeling is especially important because it makes project maintenance easier. Yeah. There's multi-cloud support. So there's actions available for each cloud provider. As you saw, I'm just deploying it to Google Cloud from GitHub Actions because it doesn't have its own cloud. And then workflow files using YAML. As you saw, the YAML configuration, pretty easy, pretty straightforward to follow through. Caching dependencies and build outputs to basically have faster workflows, right? Community of devs maintaining actions, again, can be a good thing, can be a bad thing. You get a plethora of actions available, but you always have to make sure that they are not malicious. There's support for self-hosted runners. So if you want to bring your own runners, you can do that as well with GitHub Actions. Again, it's free for public repositories. Otherwise, it's pay as you go per minute model. Actions, as I said earlier, with versions, you need to update actions or pin hash every time. So, which is something to be mindful about as your progress, as your project goes over time, right? Develops over time. Then again, you need to pin action versions, as I said earlier, and then there's malicious actions available, right? Like from third-party developers, since it can be it's something that can be misused. So we have a simple Nginx basic site, which I showed earlier as well when I was sharing 4 screens and deployed it to everywhere. But this is the site. And then we have GitHub as the source repository for the demo, where we deploy to each of the pipelines. So in terms of Google Cloud Build, GitHub Actions, Azure Pipelines, and AWS Code Pipeline. We build it, we push it to container registry, and we deploy it to Kubernetes in terms of for code pipeline to EKS, Azure pipeline to AKS, Cloud Build to GKE, and from GitHub Actions, we deploy to Cloud Run. Yeah, and these are the URLs. If you guys are interested in opening them up on your machines as well, yeah, you can just go through those URLs as well. You'll be able to see it. So it's time for demo. Let me, okay. So these are the 4 screens I have available. As you can see, again, reiterating once more, this is deployed to GKE. This is deployed to AKS. This is deployed to Cloud Run, and this is deployed to Azure Kubernetes service, right? What I'm going to do now is make a small change in my code. So this is the code base for all the pipelines. I'll walk through, I've mostly walked through each of the pipelines, but I can again go through the pipelines over here, I guess. Basically, YAML configurations, we are doing nothing. We are defining our stages. For each stage, we are defining our jobs. And for each job, we are defining the steps we need to take. And then we are defining the task for Azure. Similarly, the second stage, deploy, you would be able to see in the UI. And personally, I like Azure UI the best, but I'll go through that when I show it to you guys, right? What we are doing over here is this is the deploy. What we are using for deployment is our pipe, like the manifest files for each of the cloud providers. The manifest files reside in our K8s over here. So this is for AWS K8, which are basically they are all similar, except the image changes for each of them, right? And the GitHub workflow, this is the GitHub YAML file. So for GitHub workflows to set up, you should have a .github and then workflows directory. And in that you can specify this name as anything, and the workflow would just pick it up. Like the GitHub Actions would just pick it up. In GitHub workflow, we are pushing it to master branch. We are checking out the code. We are setting up Google Cloud. So this is pretty cool, right? Like we just provide, the secrets are maintained in our GitHub secret manager. We just use this action from Google GitHub Actions. And over here, if you see, I am using master. So I can do this as well to make sure that I always get the latest code. So I am using the the code from the master branch of this particular action. I'm setting up the Google SDK, authorizing it, setting up everything, does it automatically. Then configuring Docker. This again, this is the Google Cloud command which configures the Docker, and then I'm building the image, pushing the image, and then deploying the image to Cloud Run. Similarly, for build spec YAML, this is again pretty straightforward. Setting up everything, building, and then deploying to Kubernetes. Cloud build YAML, same thing as I showed in the slides as well. I am basically building the image, pushing it, and then deploying it to GKE using the KX. So, and this is just a static HTML file. I'm just going to make one small change over here. Let's say, hello, everyone from, and then I'm going to push it upstream. If I'm fast enough, you should be able to see the pipelines, but I can show you guys minor change made. you guys should be able to see the pipelines running. So actions is, let me refresh. And as you can see, Google Cloud is already running. Actions is running. Pipelines is running. And then the build in code pipeline is running as well, right? Let me let me go deeper into, let's say, my favorite Azure pipelines. If I go, and I'll go through each of them as well. So these are all my builds. These are all my runs, if you see. And then there's a nice UI where you see the dependence, like your build stage and your deploy stage. If you want to see more details about it, you can see each of your job that you created. You can see the logs for each of the job. It is pushing it, and then it is going to deploy it, right? And as you can see, there's like boards over here. The boards has like work items, backlog, sprint. You can maintain everything over here. Repos, again, it has like everything. Like you can maintain your repos. Since we are using GitHub, we are not using repos. And you can define your test plans. You can push your artifacts to artifacts if you wish to do so as well. Let me just make sure this goes through and it is deployed. Google Cloud build already went through. Maximize it so that you guys can see the UI. So over here, you'll see all the steps that have been done. So these are triggers basically. So we define like a trigger and we hook it up to our repository. And then you can see the logs for each of the steps. This is pretty fast, like it took 33 seconds to do the whole build. I'm pretty amazed by how fast it is always. You can also go to the dashboard and see your build history, and there's like a nice graph which shows you how many builds failed, like which one. And then you can like, basically you can get like, you don't need to go through each of the builds to see. You can just scroll through over here and see the basic information, right? You can see the pass fail percentage and all those things, which is pretty cool. For AWS, there's pipelines. This again gives you a nice UI to see your pipeline. Since we only had a build pipeline in this where we were doing the deploys as well. You can see it fetched from the source and it did the deploy. You should be able to see details. If I click on details, notice it goes to code build, and it basically goes to the build logs, and you can see your build logs from the 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 pipeline or the code build. For actions, I'm going to do this. For action, since we had only one action, there was only the build phase, but basically you can have multiple workflows. You can have a build workflow, you can have a release workflow, you can do complicated things with workflows. It gives you more of configuration options if you must. And this is how the UI looks like. It's basically, it's setting up the job, it's checking out the repo, it's setting up Google Cloud, it's configuring Docker with the Google Cloud, and then it's building the image, and then it does a push and a deploy. Yeah. Okay. And just to verify that all of this worked and I'm not crazy, I'm just going to refresh each of them and make sure the change. Cool. So as you can see, the change went through in each of the clouds. We did the deploy and it's available everywhere. And it was as simple as just setting up these YAML files, which are like hardly anyway. So yes, let's go back to the presentation again. So what are the key takeaways from the demo that I showed you, or from whatever we talked about right now, right? So as we can see, cloud managed CI/CD services, it reduces overhead to maintain self-hosted runners. As you see in our YAML files, we are not doing, we are not running like thousands of commands manually to like install, let's say, a package manager, let's say npm package manager, or assigning, like updating the environment variables, or even doing anything. So it reduces all those overheads. There's cost reduction with pay-per-use plans because you only pay for what you use. And then there are also free minutes available, which you can leverage as well. There's minimum configuration, as you saw. There's hardly like 15-20 lines of code for to deploy, to do your deployments as well. There's dynamic scalability. So this is like when your build packages is long, or if it takes a long period of time, you don't have to worry about timing out, or oh, what if there's not enough space on my runner, it automatically scales. Also, one important thing to note over here is, let's say you're a startup right now, and you decided to use Postgres SQL Server on your static side. You're just calling, you're just making calls to the database, right? And as you grew, you decided to switch to Node, you decided to use Express, you decided to use multiple things, you decided to use Redis, and all of these things are easily like this. So basically the scale of your application grew, right? So the configuration is as simple as adding an action into your YAML file, right? So it allows for dynamic scalability as well in terms of your architecture, in terms of your code, and also in terms of like your build artifacts, right? And since you can hook up build artifacts to the cloud storage solutions, uh, be, be, uh, it can scale up like infinitely, right? With like proper retention period, when you set like proper retention period and everything. Moving on, there's flexibility again, as I said. Oh, if I decide to deploy, I don't know, a node package, I can deploy a node package. If I decide to deploy Go, if I decide to move it to a .NET application, I can use a .NET application as well. And security, this is very important because there's tight integration with IAM, so you don't need to manage accesses, or you don't need to worry about SSH keys. In self-hosted world, you would give like, let's say, SSH key on your runner, and then you will have like public SSH keys, and you'll need to manage all those things, and then give access to users, or basically have your own role management system. But since every cloud provider has its own IAM, and you can integrate the each of these builds with the IAM, and then it stays mostly within the private network. So you can, if you want to just keep it within the VPC, make it not accessible outside, you can do that as well. So any questions?
Just one question I had was, when you showed GitHub Actions, especially, you show that where it was deployed, other things were deployed like Amazon, like Kubernetes, and then like that, right? But for GitHub, you show like Google Cloud Run. Is that like we can deploy it anywhere, or when using GitHub Actions especially?
No, you can use Google Cloud Run. So basically, you can use, let's say, if you wanted to use Cloud Build to deploy to Cloud Run, you can do that as well, right? Just for the purposes of the demo, I chose to deploy to Google Cloud Run. But you have actions available for EKS. You have actions available for like Kubernetes. You have actions available for multiple things, right? And then once you use the action, there's like basic things you need to provide, and it takes care of all the configurations. And then you just need to provide it like the proper necessary arguments if you must, you need to. There's one more thing. I can show you one more actions if you're, let me see. So this was an action that we worked on earlier as well. In this action, we were deploying it to we were pushing it to ECR, and then we were deploying it to EKS, and we just needed a task definition file, right? So this was like as simple as just using the available actions available from AWS, right?
Okay, thanks.
Any more questions?
Just one question, Varun. So does Azure or AWS, do they provide the CI/CD services on hybrid environments?
Define hybrid environment.
So like on-premises servers as well as
Yes.
managed servers.
Yes, you can bring your own self-hosted servers. You can bring your self-hosted runners to each of these pipelines as well. This is particularly interesting because like if let's say if you have some services that you are managing on your like on your company's server or whatever, right? And you want to do a incremental move to cloud, right? Basically, obviously the cost associated with it might be higher. You might have to look into that, right? But what would you use is like you will create a basically virtual private network where all your resources will be put into that network, or all your resources would be given access to that network, and then they would be able to communicate with each other as well, right? And also, if you have like some custom things which are not supported, you can create your custom actions as well. And this is supported on AWS as well as Azure. So you can create, I mean, all four of them basically. You can create custom actions which are specifically tailored to your particular organization's needs.
Got it. Thank you.
Just to point out one specific thing, yes, you can create custom actions and all that, but so far what I have seen, and Varun can confirm, the self-hosted runner, which means you can host them on your own infrastructure or within your wherever you want. I have seen only for Azure Devops and GitHub Actions. I don't know if it's supported for AWS Code Build or Google Cloud Build though. Have you seen, Varun, anything for those two?
No,
We
so
have
you
used
will
for
have to.
Azure DevOps, definitely. One time we tried to run the runner on a Kubernetes cluster. That was weird. But then, yeah, GitHub Actions as well, because GitHub Actions, of course, I mean, they don't have any cloud right now.
Yeah, you're correct. Like, and I'll show. Okay, let me go over here. So what Praveen is talking about basically. So this is something that I like as well. Like instead of I showed you guys pipelines, right? But let's say there's like releases as well, and this gives you a more UI thing, right? Where you can create your releases, right? Like you can get your artifacts. You can create pipelines, dump your artifacts somewhere. You can hook up your artifacts, and then you can set up your jobs as well. And over here, you can basically create your custom agents as well, which is pretty interesting based on whatever you need.
And this is where you can add an additional agent pool, which can be self-hosted.
Correct.
That you can bring it out, and then maybe there is some configuration there. So,
And just since I'm already over here, you can basically use, let's say, ARM template deployments, which I was talking about earlier. And this just generates this UI for you. And then let's say if you have an artifact, you can just point it to the artifact, the location for the ARM template from your artifact as well, which is nice. Yeah. Any more questions? Did I answer your question correctly? I'm sorry.
Yeah, Varun. Yep, got it. Thank you.
cool. Any more questions, ideas, discussions?
I'm going to stop sharing my screen.
Yeah, cool. Thank you. Thank you, Varun. One last point I wanted to make here is specifically what stage of the company would probably be looking into this kind of services, right? So the first decision, anyways, is okay, which cloud provider you are on, right? If you are already on one of these three cloud providers, that's one decision you have made before. So maybe you should look into if the services from Google Cloud, if you are using Google Cloud. So if cloud build, cloud artifact, and anything is gonna be useful for you, right? If you are on AWS, that entire tool set that you have. If you are on Azure already, using Azure DevOps, they are making a lot of progress on Azure DevOps. We started using it almost, I think, a couple of years ago, or maybe 18 months ago, for one of our new customer who was on Azure, or who we helped to move to Azure. It's a small start. I wouldn't say small now, but at that point we thought, you know what, it will make sense. Everything is there. Now, apart from that decision, the next one will be if you are on GitHub, right, already. And in our experience, a lot of companies now are moving from their self-hosted version control on Bitbucket or Stash, or other pieces, now moving to some of them moving to GitHub. So if you are there, you can utilize maybe GitHub Actions or GitHub Packages, right? A couple of those things. For small startups to mid-sized companies, if you are already on Azure, I think you don't even need any other tool if you get comfortable with Azure DevOps. For project management, meaning your replacement for your Jira, Wiki, it has pretty good. Access management is already there using Azure AD. Maybe you are already having it. And then, of course, pipelines, releases, test plans for your QA team, artifacts, everything they are bringing up, right? I think there was a big push to move from what used to be there, Visual Studio or TFS or something, Varun?
Yes, yes. The Visual
Oh, yeah,
Studio.
VSTs or whatever. So they are rebranding it, and then moving and making it more tightly integrated with Azure. Now, again, remember, Azure DevOps is not fully integrated with Azure Cloud. So there are some things here and there with respect to how you authenticate from one to another, but still more and more time they are spending. I think it's going to be a one concrete solution, just like AWS side of the world that you have.
Yeah.
In my experience, Google Cloud has or is farthest. Oh, sorry, yeah, it's very behind in terms of feature set, right? I mean, you just saw the UI. That's maybe if you want your users to never, or your developers never to look into the UI, but maybe have some sort of your source control based some sort of scenarios, or maybe automation or pinging them to Slack, maybe it can work out. But on a larger scale, although the builds from Google Cloud build are so fast, you run it within 33 seconds or so. It was able to build an image, push it to GCR, and deploy it to GKE. Apart from pulling it from GitHub as well, so it was damn fast. Somehow it can allocate those agents very fast, unlike Azure DevOps, which was probably the last one. Maybe your build was sitting there waiting for agent to be allocated, maybe because you are on free plan, Varun. You should start paying for it. So that
And
may
this
be.
is a classic case of performance versus better UI UX.
Yeah.
Again, right? Like, yeah.
That is the what else? I think, yeah, those were the points. Definitely the custom actions or community actions. Whenever we have used the word actions, that means some pre-packaged build step that you can get it. So Azure DevOps is there very well. A lot of work done from Microsoft and other folks. GitHub Actions, a lot of work done by other cloud providers officially, and then given to GitHub Actions. So those are there. On AWS, nothing is there, so you roll it out your own, or you probably customize and build it there. Google Cloud, I haven't seen anything outside. Maybe it's again. I think Google Cloud has those things, right? Those.
Cloud builders are there. Yeah, they maintain a repo.
Perfect. So that's pretty much it for today. Oh yeah, Yanni had a question. How does GitLab compares to those? Good question. Varun, you have any clue? Because I have no clue.
So I have worked with GitLab previously in my previous company. What happens in GitLab is you have to bring your own servers. As far like when I was working there, I don't know the current state of GitLab right now, but you have to bring your own self-hosted server, like hosted runners, and then you have to do the builds again. There's no support for actions or like the CI/CD stuff, but GitLab was, I think, initially the like one of like it came up with this idea of CI/CD integrated into your source repositories previously, but you still had to bring your own server. Yeah.
maybe we should try out putting another meetup down the line on maybe picking up two of them, and then I don't know if GitLab can be one. I don't think any one of our customer right now is using GitLab at this portion, right? We have a lot of folks on GitHub, definitely. Then whatever we are helping them, couple of customers still using Jenkins, but I am damn sure in the next year or so they are thinking of moving from self-hosted mess into something that they don't have to worry about. That's the benefit of going to cloud, right?
And one point I like to mention also is like when using Jenkins or something, the auth needs to be done through Okta or like some other third-party provider, right? You don't like with these particular things that I demoed today, you can integrate it with IAMs and you don't have to like think a lot about auth into into either builds.
Yep,
Right?
yep. That's one of the things. What I was surprised was, I mean, all these cloud providers, or at least AWS, right? Is it's known for picking up a open source project and then making it as a managed service. Why didn't they think about Jenkins? Or maybe they thought about it but then dropped it. I don't know. They have tendency of doing it. So a self fully managed Jenkins as a service. I don't know. That was one of the things. But anyways, interesting stuff. Cool. Any other questions? Any thoughts from anyone?
If
Otherwise, we'll have.
if any big enterprise organization has more than one cloud, let's say all clouds, okay, and they wanted to build the pipelines, and I mean, yeah, Varun showed that which one is providing cross cloud support and which one is not. Made that segment I kind of missed it, but then cost wise plus number of build, let's say number of builds are in the same organization are same, right? So they all having all three in an enterprise with the same number of builds, which one should be preferred over the other and why?
So, yeah, go ahead, Varun. Then I will take it.
Personally, since majority of the people use GitHub as their source repository, it would be wise to use GitHub Actions since you have a large community of actions available as well. So you don't have to, let's say, these are the three major cloud providers we look at, right? But for future perspective as well, there's IBM Cloud coming, and you want to deploy to IBM Cloud as well, right? In the future there might be some action developed by IBM or someone, right? Since GitHub is like widely used everywhere for that action. So I would say in terms of high availability of new feature sets, GitHub, I personally would prefer GitHub over others. Again, cost wise, you would for your particular use case, you would have to evaluate your use case and see. Basically, Azure, as I said earlier, you can buy the whole package at once, or you can separate out and pay for each thing that you want to use, right? Similarly, that's also true for like Google Cloud, and that's also true for AWS or basically any other or Azure as well. AWS is the most restrictive because if you want to from let's say code deploy, if you want to deploy to other clouds, you would have to manage everything. And let's say you're using code source repositories, you would have to manage everything manually, which would give you a very less benefit in terms of moving away from self-hosted to a code deploy or a cloud-based CI/CD service.
Then checking up on I think he answered well on the multi-cloud support, right? If you don't want to tie into one cloud and then want to stay out of it, probably GitHub Actions. I would still say it's bleeding edge at this point versus maybe some of the more stable one. But if you are already an enterprise, assuming you are supporting, you are thinking of going into multi-cloud, then you may have a team already to manage your CI/CD services or operations, right? Then what it means is, okay, maybe then look forward or look towards one of the solution, at least three out of the four that we have, where you can maybe roll out something custom. Maybe you can use something which is available from public, but then customize it for your needs, and then create that repository internally of actions, whether it's on Azure or whether it's on AWS or also on GitHub Actions. So that is one other thing. From the cost perspective, the interesting thing to note here is Why you save the cost? The reason is because these are all pay per use, meaning they are all of them. If you see, their cost model is
Pay as you go.
minutes per. I mean, yeah, pay per build minutes, meaning how long that build is running. So let's say if the build is running for 3 minutes, you are charging 3 units of the cost, right? On code build, I was just looking into their cost patterns right now. I'm talking about AWS code build. So for a 3 gig memory, 2 CPU runner or a builder, it's what, $0.005, so which is zero point 0.5 cents per minute, per build minute. So that's what it is. If I give you an example from one of a very startup-y customer, I would say in a month they were going through somewhere around 2,000 to 2,400 bills per month, and then we were paying $9 or maximum probably something like that. Now think about that versus running a self-hosted or even your own Jenkins cluster on EC2 cluster or EC2 instances, right? When find me an instance that can support that, and you only pay 3, and you don't have to worry about, hey, how do I log into my Jenkins cluster, or I need 3 builds to run in parallel. I only have 1 agent. How can I parallelize all that stuff, right? In AWS code build.
Yeah, and also scalability. Let's say you assign an EC2 instance a particular.
The, the one thing why I think we wanted to put cost analysis here as well, we should have put, but the whole idea was uh, it all depends on how many builds you are going to be running, build minutes, I should say, and then what is the size of that builder, right? So usually when you, in some of our projects, like for example, when they were running Jenkins, they had predefined builders size, right? Size configuration, whether you want a 2 GB builder or an 8 GB builder, depending on what the heck you are doing on those builds. More options are available from all of these cloud services. So you can pick and choose. Maybe for your Nginx static side, the way we had it, maybe you will be fine with one of the smallest builder or runner. But then if you have a heavy test suite or integration tests and things are running, you maybe want to choose a larger one, right? That is one definitely an example. By just changing the agent type, you can pull something else from the cloud. The other piece was, you will see nowhere we were required to install Docker, or we were required to install AWS CLI or kubectl to install, right? Or binaries for Java or Go or NPM or anything like that. Most of them are actually available on this predefined build agent, and they are just running as Docker containers behind the scene, mind you. So they are there, and then if you want to create your own agent using a template, you can do that as well. I think that's where most of the work, if you are in the enterprise group and you have a CI/CD team, that's where you will be doing. Okay. Any other thoughts? Any other questions from anyone? Cool. So let me just share some last pieces, and then we'll be done. So next week, right? Yes. I will be taking 2 back-to-back sessions. So next Thursday and the Thursday following to that. So March 25th and April 1st. And the whole idea is to discuss something, again, a bleeding edge technology called Service Mesh. And we will be focusing on Istio, of course, on top of Kubernetes. So the next session will be more intro level. We will go through how Kubernetes services are handled by default, how the service discovery happens usually, right, without Istio, and some of the features and how to install Istio. 2 weeks from now, we will be going into an advanced session where we will be going through some higher level topics of doing canary deployments or encrypting service to service communication, or doing chaos testing, or doing maybe some sort of traffic shifting, right? Rate limiting and stuff like that. So some heavy advanced concepts. But yeah, next 2 weeks, next 2 Thursdays, I should say, those are all dedicated to Istio Service Mesh on top of Kubernetes. So I think this is the last time. If you have any questions, any thoughts, otherwise we'll leave you here and then see you next Thursday. Cool. Thanks everyone. Take care. Bye-bye.
Thank you.